All right, two-stroke turbo fans, welcome back to the shop. Welcome back to working on two-stroke cars. We're actually going to take a break on working on this old two-stroke car. I've been working on the grill, getting the belts to line up, getting the hood to latch, getting the headlights hooked up, kind of getting all the front end stuff all sorted, and so I can drive this thing. It's still a long ways to go. Had this car for many years. It runs and drives, but now needs turn signals and headlights to be complete and to be a good car. It also needs bumpers and needs paint jobs, needs a lot of stuff. But I think I'm gonna take a break on this for now. I really want to drive this car. And it's been bothering me. I've been having wheel bearing issues. If you've seen the last couple of videos, I've been frustrated. I think I've got a solution. In fact, I'm quite confident I have a solution, and I'm going to show you what I got going on. So this is a 1959 Vespa 400. Normally it would have a two-cycle, two-cylinder, 393 cc engine. It has a Volkswagen engine, and it's not my creation. Somebody created it in the 70s, I believe, and I really enjoy this car, but the engineering is not great. Obviously it's been throwing wheel bearings, and that's not good. I don't like having a car that binds up or throws a ball out the wheel bearing. That's no fun. That's not part of the driving experience. So come over here to the workbench. I'll show you what I got going on. So if you recall, this car had wheel bearings in it that are what are called roller bearings. And if you look there at the grease seal, see, it's all warped. It's all heat warped. This bearing is almost ready to seize up. The ones that did seize up, they completely shattered and broke. I feel like there is some axial pressure on these bearings. These are roller bearings. They're not made for axial or thrust bearing pressures. They're good for radial. In other words, up and down, like this way, rolling. Tapered wheel bearings like this that you have in your boat trailer or any other wheel car bearing application, they can take some axial or thrust to them. So I'm going to put these in. They're heavier duty. You can see the bearings are longer. There's much more contact area, and they like to be kind of pressed together. So I'm going to take my hub here, which is in the vise. I'm going to drill a hole in it, put a grease Zerk fitting in like this, so I can actually grease them, because these are not sealed. I will grease them before I put them in, but to keep them greased, I don't have seals for them, but there'll be a tapered roller bearing here and a tapered roller bearing here instead of the just simple roller bearings that are not tapered. I'm just worried that I don't have enough thrust capability or thrust load capacity on these roller bearings, and I think that'll do it. So I'm going to start with the left rear, and then we'll do the right rear at a later date when those bearings explode or blow out. Right now I'm going to drill a hole right here in this hub, and it'll put in a grease port basically so that I can grease the bearings just by forcing grease in and out the side, and then I could wipe them off, I think. And that'll be good. Now, this one here will be covered by the dust protector of the drum. This one here, though, is going to sort of expose the CD axle, which will be like this, will be in here. And it should keep most dirt and grit from getting in there, but that bearing will be exposed. So tighten this up a little bit. Follow my toe. So let's get this thing going. I want to get this car back on its wheels and see how this bearing expedition experiment works out. So I bought a whole 10-pack of these tapered bearings, and let's put this baby together. Okay, so we're working a little bit more on our Vespa wheel bearing project. You can see I've got the hub back together here. I've got a Zerk fitting or a Zerk nipple on my hub. I put in 2 tapered bearings on the drive axle side and 1 on the output side or the wheel side. And the way it's going to work is when I tighten the nut for the hub or the drum, it should pull those bearings together, and I'll have typical bearing clearance. I can, tighten it up and then release it and figure out how the bearings, like a normal, like Ford or Chevrolet. So out go the roller bearings, which have great radial strength but no thrust strength, and I put in the tapered bearings, which have good both radial and axial or thrust strength, and I took out the spacer that goes in between them. Otherwise I wouldn't be able to get bearing preload, so I can adjust that. And I just tried and pumped up my hub. I used almost a whole tube of grease to fill this until, I pre-packed the bearings, but then I also filled this up until the grease shot out. I don't have any seals on here. I'm a little concerned about getting dirt in there, but I don't know. I got to do something to keep these bearings alive. So now the trick is getting the hub back in there and getting it aligned and testing it out, and then do the other side. It's kind of a lot of work, but what isn't a lot of work? Okay, so we made some progress. We got our wheel bearings back together. Wheel turns fine. It's got preload on it, and the drive axle is pretty cocked when it's in the hanging position. When you set the car down, the axle becomes more level and it rolls better. And that might be my problem, actually. It might be the torsional problem with my axle causing my bearings to fail. I don't know. I've got the tapered bearings on this side, and I left the roller bearings on this side. I just want to drive it. Although I feel like it's pouring down rain outside. I think I can hear it. It's not going to be fun to drive. And it is pouring rain. It is pouring rain outside. It's going to be not very enjoyable. Drive my little roller skate. I think I may just jump on to the next project. What would that be, you might think? I haven't tested the wheel bearings. I don't know if the wheels are going to fall off, but yet we're going to try to increase engine performance. So I've got these high lift rocker arms I've been wanting to set on this thing for a while, or I've been setting on. I want to put them on this car for a long time. So pop the wheels back off, get the valve covers. I was going to do a valve adjustment anyways, but I think I'm just going to put these rocker arms, and I've got to get the geometry correct. So I've got the shims. Should be everything I need. These are 1.25. The original rockers are 1.1s, I believe. So let's pop off the valve cover bales and see what we got in there. Okay, so I've had these high ratio rocker arm assemblies for some time. I've been wanting to put them on. I'm going to pop the bale off here and see inside our Volkswagen engine. This is a dual port engine. It's stock. I'm going to get my oil pan here just in case it floods the area with oil. Yep, I knew it would. The oil looks kind of bad. Looks like it's got water in it. Should probably change that. Let's see what we got. So yeah, it looks pretty old and tired in there. Probably time to swap out some rocker arms. Been told that this is not a good idea, but I always listen to everybody. So yeah, I've got to get the geometry right. I do have shims, and the new rockers will not change the cam duration. They'll just change the lift. Some people say that it makes a difference. Other people say it doesn't. So we're going to try. And of course, we've done that. We're working on the engine without even taking a second thought about our wheel bearings to see if they stay in place. But let's get to this. So I just have to pull off these two rocker arm stud bolts and then hook everything up and adjust the valves on the new rocker arm stands. Okay, so I got the new rocker stands in. Unfortunately, I don't think they're going to work. If you look there, let me turn the light on here. There we go. I need like a 1/4 inch spacer or shorter push rods to make these work. These new rocker stands have quite a beefy trunnion and the bushings are super nice. They're super high quality. I'll show you the difference here. These are the stock ones, and the adjustments are on the valve and the valve tip, and mine are all worn, of course. You can see my valve tips are all kind of wore down. The new heavy-duty ones, have the high ratio rockers, the adjustments on the push rod end, and these have a roller, kind of like a cam follower. It looks super nice, but I don't think I can install them. I just can't get close. I can't even bolt them on because I need shorter push rods. That's a real bummer. These would be a nice upgrade, but maybe for the next engine. So I think I'm just going to put the stock ones back on and say, well, we tried. Not putting on the high ratio rocker arms is a total bust. I didn't know that I checked my head bolt stud or bolt tightness, and all of them were loose, so didn't torque them down a lot, but I got them snug again, so that should help keep my heads on. Went through the box. I did find the instructions for how to cut the push rods and insert the ends. I don't really feel comfortable doing that right now. I'm going to pop the other side off, the other bail, and check valves and just tighten the heads and see how she runs, I think. And if I get all frisky, I can put the really cool rocker arms on, but for now I think I'm just gonna, this thing's gonna pop off here. Oh, here comes the oil. It looks like it's got water in it, but it's not a water cooled engine. Maybe it's got moisture. So I'm gonna adjust the valves on this side, tighten the head, and then I might take the engine out and see if I can fix the clutch. The clutch has been kind of an issue. It's been slipping. Not slipping, but it's been shuddering when it's cold. I think I've got an oil leak. Maybe we'll get to that instead. Fix the basics first, right? So I just pulled this valve cover off. I mean, that says there's moisture. How can there be water in the engine? It's an air-cooled engine. I don't get it, but that's definitely got a lot of moisture in it. I gotta drain this oil. Figure out why it's getting moisture in it. So I guess moving on from one problem to the next, I've been rotating the engine over, probably turned it over 20 times. None of my valves had any clearance. I think maybe one had 4 thousandths. Now they all have 6. They're all supposed to have 6 thousandths when they're on the base of the cam. So, I can't believe this thing ran. And I noticed my generator pulley, my belt is all floppy and my pulley nut is loose. Oh, kind of a mechanic am I? My exhaust fan pointed out the shop. I think we're ready to fire this thing up. It's probably going to clatter now because the valves were so tight for so long, it was silent, and I kind of like that about it. Now it's probably going to have a typical air-cooled valve train noise. All the valves now have 6 thousandths. None of them had that. Let's fire it up. Let's see if I can. So I'm going to pump the gas. Make sure it's in neutral. Twist the key. There we go. Still got some belt issues going on here, even though I tightened that up. You can hear that belt slipping. Looks like it runs okay. I hear a little bit of valve clatter. Okay. Seems like it runs all right. It's got good compression. Turn the key off. Now I got to decide. Yeah, the belt is still too loose. Need to mess with the shims in this a little bit and get that a little tighter. I need to decide if I want to tighten the top head bolts. I'd like to do that, and I think I'm going to do the clutch. So it's pretty easy to pop this out. 4 bolts, they say. Just the wiring for all the stuff needs to come out, and end play. That's right, I got to check the end play. I think it's got excessive. Oh yeah, I can feel it. Look at that. I think I can shim that. I hope I can. It gets an oil leak when it's hot because of the end play. So Maybe a new rear main seal, new clutch. Let's see what we can do. My shop dog Stella, what are you gonna show the folks on YouTube? How to yawn, how to stretch, when I catch a squirrel. Oh, we just caught a squirrel. We got our motor out of our Volkswagen powered Vespa. I don't know what this is. There's a ball of copper inside the bell housing. Never seen that before. We gotta take a look at this thing. It's oily in here. And I know the clutch is oiled up. Looks like it's got a aluminum flywheel. I didn't know about that. I don't think that's possible. But anyhow, motor came out pretty quickly. I'm going to break this down and see if we can fix the end play of the crankshaft, new rear main seal, new O-ring for the flywheel, and maybe seal up stuff in here, new throw-out bearing. These mounts look really bad. I might be able to replace those and see if we can get maybe a stronger clutch on this thing. Do some wheelies, huh? Stella, what do you think? You like doing wheelies? What are you doing? Sniffing a box? All right, well, I knew these things were bad, so I ordered up some new ones. Look at the difference. Those are nasty. Nasty. Nice. Hi, Stella. And then on our clutch here, it is oiled up. I mean, that is one oily clutch. It's not wore out, but it's leaking oil. I mean, it's just full of oil. I gotta fix that. It's not too bad, but okay, let's see if I can get that off there. I don't know if I can get that off there. It's a 300 foot-pound nut. Let's see what I can do. Okay, so I got my flywheel off. Still an O-ring in there, but it's hard. And the flywheel's actually been rubbing on the main seal. There's so much end play. Looks like there's a few shims in there. I hope I can shim this. What a mess. All right, I think that's where we're going to leave it for today. Now I got to buy some parts and figure out what all this copper is doing in here. I don't get that. I don't know if something fell in there and got wound up. There's no copper. There's a big ball of copper inside the bell housing. No idea where that came from. I guess I'll figure it out. It's a mystery yet to be solved.